Okay, so we're going to have a look at another question. This comes from the 2022 HSC Advanced Maths paper. So this is question 32. This is parts B and C. So question 32 is one of the harder questions in the paper. B and C are fairly rigorous parts of this exam, so these are somewhat challenging. So we're told after 100 repayments of 1,381.16 have been made, the interest rate changes to 35% per month. At this stage, the amount owing to the nearest dollar is $100,000 and $100,032. Jane continues to make the same monthly repayments. For how many more months will Jane need to make full monthly repayments of 1,381 and 16 cents? Okay, so we're going to continue to use the same formula we used above. In this formula, you see 3 iterations of 25. 25, 25, 25. We're going to change these to 35. So AN is equal to P times 1.0035 to the N minus M times 1.0035 to the 35 to the N minus 1 over 0.0035. We built this shorthand version of the AN formula in part A, so we know that this works. So she's going to continue to make the same repayment. The loan that she's borrowing, the P value in this case is essentially the 100,000. 100,032. The M, the monthly repayment, is kept the same. So the M is now 1381.16. Now, we have a bit of a problem here. We know P, we know M. We don't know AN, and we don't know N. Now, in this question, we need AN to be equal to 0. That's actually what we're trying to find. We're trying to find how many months with this particular financial arrangement will she have to continue to pay 1,381.16 in order to pay this loan off. So we're trying to find N under these conditions. So let's plug our numbers in and rotate this around a little bit. So we have 0 is equal to 100,032 times 1.0035 to the N minus M. I'm going to expand the numerator here. M over 0.0035 times 1.0035 to the N plus M over 0.0035. Now, of course, we know that M is 138.116, so we can plug these in as well. So this is 1381.16. This is 1381.16. Now, this 0.35 can be simplified into this, but we're actually not going to do that. We're going to multiply everything by 0.0035. So multiply this by 0.0035, multiply this by 0.0035, cancel these by multiplying both of them by 0.0035, 0.0035. This gives us 0 is equal to 100,032 times 0.0035 times 1.0035 to the power of n minus 1381.16 times 1.0035 to the power of n plus 1381.16. So we need all of the terms that have 1.0035 to the power of n on one side, everything else on the other side. So we will minus 1381.16 from both sides. That's 1381.16. This looks really complicated. This is actually not particularly complicated. It's just algebra. It's just algebra with numbers which contain decimals. And that gives it the illusion of being more complicated. So minus 1381.16 is equal to 100,032 0.0032 times 0.0035 times 1.0035 to the power of n minus 1381.16 times 1.0035 to the power of n. I'm now going to factorize 1.0035 to the power of n from the right-hand side. So this will give me minus 1381.16 is equal to 1.0035 to the power of n. I will have this term minus this term in the brackets. Now I'm actually just going to put that into my calculator straight away because it's just getting too long. It's not really going to matter whether we numerically estimate this right now or not. So 1,000,32 times 0.0035 minus 1381.16. This is, I can write this as a decimal or as a fraction. I'll just write it as a fraction. Minus 12881 over 125. Now I'm going to divide both sides by this. This gives me minus 1381.16 divided by minus 12881 over 125 is equal to 1.0035 to the power of n. Now this is a stupidly complicated expression. At this point it would be entirely sensible to decimal approximate this, but we don't have to. Right? We can now apply logarithms to both sides, so we can take the natural log, we can take ln of this side if we really want to, ln of this side, pull the n down the front, divide both sides by ln of 1.0035, and approximate this for n using the calculator directly without having to do any numerical simplifications. So we have a ratio of logs. This is ln of something divided by ln of 1.0035, and then the log in the numerator will be this log here. So this will be fraction, and then in the denominator of that fraction, another fraction, minus 1381.16 divided by the fraction minus 12881 over 125. My calculator tells me this is 83.674078 ... So how many more months will Jane need to make full monthly payments of 138,116? She will have to pay 83 full months. And it's 83 full months. And then one partial month. Right? So the rest of this string of numbers here solving for the n, this corresponds to one partial month. So this is the answer here. And this is the answer to part B. So for how many more months will she need to make full repayments? 83. The final repayment will be less. So this is part C. How much will Jane need to pay in the final payment in order to pay off the loan? So the shorthand way to do this, the quickest way to do this, is to take this string of decimals and multiply it by her fixed payments, and this will give you the fraction of the payment that would be needed. So that's what we're going to do. We are going to say the final payment, which we'll call f of p, is approximately equal to 0.674078 multiplied by 1381.16. This implies that the final payment is approximately equal to 0.674078 times 1381.16. This gives me 931.00957 ... Therefore, the final payment is going to be about $931. Could be $932 to cover any additional bank fees. Could be $931.01 if you're rounding to two decimal places. But this is the portion of the payment that she will have to make in order to pay off the loan completely under these new terms. So 83 full month payments, one extra payment of about $931, $931, $932, depending on the rounding.